Okay, so today we are going to be looking at 2.7, which is parent functions and transformations. We're going to be doing day 1 today. So really ultimately your goal is to be able to identify and use parent functions, and then we're just going to start scratching the surface of describing transformations of functions. So a parent function is the simplest form of a function in a function family. All the other family members are variations of the parent. So they all have the same key feature, and then they all have the same general shape as well. So linear functions, for example, are the parent function would be y equals x. And we know that there's a lot of other lines that have the x in it, but the parent function, the general shape of that parent function would be just a straight line going through the origin. Now, we might shift that, we might stretch it, we might change the slope on it. So other examples of the family members would be like y equals 2 times x, or y equals 2x plus 3, or really y equals negative 3 halves x plus 4. Notice that all of these still have that key feature of just the single x in them, and then the other pieces of information make changes onto that. A quadratic is what we know better as a parabola, okay? So, or kind of that U-shaped function. So the parent function here would be y equals x squared. Graphically, this is going to look like that U shape. It's called a parabola. P-A-R-A-B-O-L-A. And other family members that we might see with these ones, there's lots of them. So we could have y equals 3x squared. We could have y equals 2 times x plus 1 squared minus 5. We could have y equals x squared plus 3x minus 2. Okay, all of these are types of parabolas or types of quadratic functions. And the key feature here is noticing that there's always going to be an x squared in them. Okay, lastly, absolute value graphs would be y equals the absolute value of x. And absolute value graphs, I always think of absolute value starting with a V. Absolute value graphs make that V shape, okay? Some other family members would be like y equals negative 3 times the absolute value of x, okay? Or y equals absolute value of x plus 1, absolute value, minus 3, okay? So notice that we can just add, subtract, multiply, and divide, but the key feature here is that we still have those absolute values. So no matter which of these family members that we were to graph, they would all have the same general shape. Any of the quadratics would still have the parabola shape. They would just be shifted, maybe stretched a little bit, maybe reflected. So that's kind of what we're going to explore in these next couple of days. Okay, so here's just kind of a wrap up of those parent functions. The constant function is the straight horizontal line. We won't talk too much about that, but your book refers to it every once in a while, so it's good to know. A linear function is also known as the identity function. Okay, absolute value function and quadratic function. So what we're going to do is we're going to identify the type of function represented by the graph, and then we're also going to describe how is this different from the parent. So for this one, you can see that this is a V shape. So if you remember, this would be the absolute value graph. Okay, so my equation is going to be an absolute value. And then how is this different from the parent? Well, the parent function usually starts here at the origin, and we go like this. Okay, so how is this different? Well, this has a shift to the left 3 units. Okay. Go ahead and see if you can figure out what is this graph and how is it different from the parent. Okay, so for this one, we're looking at a parabola, which means that this is a quadratic function. And additionally, just like with the absolute value function, quadratics always start at the origin for that parent function. So notice that this is just that quadratic shifted. This one has a shift to the right 2 units. Okay? So what we're going to do next is we're going to do a little activity. That is a Desmos graphing activity. You guys should have a worksheet that goes with it. Your note sheet that you just took a couple of notes on, keep that because that's what you'll use for the video tomorrow. And now you're going to move over to the Desmos worksheet. What I want you to do is I want you to follow the directions on the Desmos activity worksheet. Feel free to work with your neighbor, that's fine. Some of the directions might be a little bit, what is this asking me to do? So just make sure that you're following them to a T and you should be able to figure it out. What you're going to do is you're going to actually kind of experiment with different ways to add, subtract, multiply, different constants to your graph. So on the Desmos screen, you'll add what's called a slider, and you will actually change those values that you're adding to see how it changes the graph. Tomorrow what we're going to do is we're going to go over the different transformations that you discover in this activity. So this is really a discovery activity for you to figure out kind of what the different transformations are. And once you're done with this Desmos activity, you are actually done for the day. So your job for today is just this Desmos activity. There's no additional homework tonight. I want you guys to be able to have a good night and have some fun tonight. So go ahead and I will let you guys get started on the Desmos activity and go to work. I will talk to you tomorrow.